if the next hop address is reachable and there is a tie in the wait and local preference, so both of them have the same value, the BGP Best Path Selection examines if the route is locally originated, and if not, the next attribute we take into account is the AS path. So the rule is simple. The shorter AS path is preferred. So the less AS hops. And if there is a tie in the AS path length, we go further to attributes like origin type, MED, and so on. But now let's focus on the AS path. We can make it longer intentionally by this method called AS path prepending. So we add our own AS to this AS path string, not just one time, but multiple times to make it longer on the purpose. Let's take the BGP table of router 6, for example. To reach router 1, we can go through AS 65007, so router 7, or to AS 65005, and we choose this lower path by default. As you can see, the local preference and the wait values are not assigned, so they have the same default value. The route is not locally originated, and also the AS path length is the same. So we have to go through two ASs. And also the origin type is the same. We have no MED values assigned, so I think the deciding attributes here simply is the router ID, and the lower router ID is preferred, so router 5. Now what we want to do on router 5 when we advertise this NRI, so 1111/32, we modify this AS path string to make it longer intentionally. And because of that, router 6 is going to prefer the other way, so through AS 65007. So on router 5, as usual, we create an ACL to match 1111/32. So IP access list extended, we name it to R1 and permit IP 1111. The wildcard mask is 000 and the destination is any. And we create a route map to match this ACL. So route map, we name this AS prepend, permit 10, match IP address. The name of the ACL was to R1, and with the set statement we modify the AS path, and we could technically prepend any AS number to the end of the string, but in real life we really only should use our own AS number. So we select the last AS, and how many times do we want to do that? Let's say 3 times. And we need one permit statement at the end to match everything else. So we increase the sequence number. This is for the prefixes which we don't want to modify. And we apply this route map to our eBGP neighbor, or rather BGP 65005. The neighbor is 10.056.6, which is the IP address of router 6. Route map and the name of the route map was AS prepend, and we apply this on the outbound direction. So we modify the AS path according to the route map and then send to our neighbor router 6. And again, I restart the BGP session and let's verify it on router 6. Show IP BGP, and as expected for the prefix 1111/32, the AS path has been modified. So now we prefer the shorter AS path, and here is the Wireshark packet capture of the BGP update message which router 5 sent to router 6. For the NRRI 1111/32, the AS path attribute has been changed to make it longer, so less preferred. The origin type is IGP, which means we use the network command to advertise this route. And the next hop is router 5's IP address, because eBGP routers always change this next hop. And as you can see, the other NLRIs are unchanged. We haven't changed the AS path in these cases because we used an ACL and a match statement with the route map.